Okay, so this is 7th grade. We're doing 2-4, and we're talking about a constant of proportionality. And so if you remember from the previous lesson, we were looking at, fractions and trying to figure out if it was constant. So write this down, k equals y over x. K equals y over x. And so that's what you're going to be doing in some of these problems is you're trying to figure out what k is, and k is a constant. It's a number that's not going to change. Miss Lagarbo, are you? Are you? Yeah. Oh my gosh. I had the L right. Miss Lamandola. Oh my gosh. Yeah, okay, brain fart. Anyways. There's that dementia again, Mr. Meredith.
Isn't that Isla's last name?
Yeah, it is. Well, she sits right there.
Okay, that makes sense.
So,
She has to sit next to Kaden? I feel bad for her.
yes, she does. She does. Okay, shh. So, yeah. Oh my gosh. Well, I should move her so I don't do that again. All right, so let's take a look at this. So it says equation to represent a proportional relationship. So it says the constant of proportionality is the constant multiple that relates proportional quantities x and y. And it's the value of the ratio of y over x and is represented by k. So if you go back to what I had you write down a moment ago, k equals y over x. So look at this little chart they gave us here. And x represents hours, and when they often do a chart for you, the first column is x and the second column is y. Well, then you just set it up as y over x. So that would be 8 over 10. And that's what they did here, 8 over 10, and that reduces down to 0.8, or if you were to keep it in fraction form, what would that be? Yeah. 8/10, which is what they have right there, but if we reduced 8/10, what would that be? Reduced. What's 8/10 reduced?
1/8.
Not 1/8, no. Mr. Moore? 4/5. It reduces down to 4/5. And 4/5 is the same in decimal form as 0.8, because if we were to divide 4 by 5, you're going to come up with 0.8. Miss Daly, would you shut the door for me, please? Thank you. And so the other two numbers, hours, were 15, and it ended up being 12 liters, 12 over 15. That would reduce also down to 4/5 or 0.8. So 0.8 is the constant, is the k. And again, if you were to look at what I told you to write down, and if I put 8 over, what was it? 8 over 10, you would get k, which would be 4/5, or in this case, to use a decimal, 0.8. And that's what this lesson is about, is often finding the k, or the constant. Okay, hold with the questions. Let's look at the try it. Down below, I helped you out with this. It says Maria made 2 batches of fruit punch. The table at the right shows, excuse me, how many quarts of juice she used for each batch. Apple juice, that's the x column, and this is the y column. They labeled it for you. And it says write an equation that relates to proportional quantities. So k equals y over x. So here we did it. It's y, which is 8. There's 8 over x, which is 5. And that reduces down to 1.6. So because 5 goes into 8 once with 3 left over. So 1.6 is the constant. And then if we set it up this way, if she did another one that was 10 cups of juice and 16 of apple juice and grape, and again 16 over 10, you're going to come up with 1.6. The 1.6 is the K, or the constant, and so you want to put that in that box right there. And so the relationship y equals 1.6 times 8. All right. Let's look at example 2 here. It says 1 inch is 2.54 centimeters. That's true. How many centimeters long is an 18-inch ruler? Now, before I go any further, how many of you know how to solve that? Okay, about half the hands, maybe a little bit more than half. Well, 1 inch is 2.54. 2 inches would be 2 times 2.54. 3 inches would be 3 times 2.54. Obviously, if it's an 18-inch ruler, it's going to be 18 times 2.54. And so here they set it up for us. In step 2, y equals 2.54 times x. X would be how long it is. All right? And so the ruler would be 45.72 centimeters long. Let's look at the try it here. A florist sells a dozen roses for $35.40, and I'm going to pull a stick asking a question about this one. She sells individual roses for the same unit cost. In other words, each rose would be the unit cost, how much each rose costs. It says write an equation to represent the relationship between the number of roses, x, and the total cost of the roses, y. And then it says how much would 18 roses cost? Well, it's going to be $35.40 divided by 12, because we're talking about a dozen roses. And you're going to end up with $2.95 per rose. Now, this is what they wanted to do here. It says write an equation to represent the relationship between the number of roses, x. X could be 18 roses, which it is in this case, but x could be 20 roses. X, maybe somebody wants to buy 50 roses. So we want to know the total cost of the roses, y. So here's that equation they're looking for. Y equals 2.95. That's the constant. That's the K. X. And in this case, X is 18. And so if you did 2.95 times 18, if I did my math right, you're going to come up with $53.10. Look at example 3 here. It says, can you represent the total cost y for admission into this park and x rides at the amusement park using an equation in the form of y equals kx. K is the constant. Y would be the total cost. X is depends on the number of rides. So here we have the number of rides. If they went on one ride, the cost is $25. Now, if it was a constant, what would 2 rides be? Yeah, just tell me. 50. What's 2 rides? 30. Is it going to be constant? Obviously not. So it says compare the ratios to determine whether the relationship is proportional. So 1 over 25, 2 over 30, 3 over 35, because you're doing y, which is the cost, over x, the number of rides. That's what they did with each one right here. And you come up with a different amount each time, 25, 15, 11, 67. So that relationship is not proportional. There's not a constant. All right, let's look at the try it down at the bottom. Remember that the K equals y over x. As balloon A is released 5 feet above the ground. So that's where it starts. It's already 5 feet high. balloon A. Balloon B is released at ground level, and both balloons rise at a constant rate, whether it's 2 feet a second or 10 feet a second or 20 feet a second. Then it says, which situation can you represent using an equation of the form of y equals kx? K, that's going to be the constant speed at which the balloon rises. X would be the number of seconds. So let's look at this. So balloon A, at what height did they release balloon A? Just say it. 5 feet. So in 1 second, it was 9 feet. So how far did it rise? 4 feet. In 2 seconds, it was at 13 feet. How far did it rise?
4 feet.
In another second, 4 feet. And then it went up another 4 feet. 13 plus 4 is 17. So balloon A is constant. Balloon B, what altitude or what height did they release that one? It was at ground level. So in 1 second, it went up 4 feet. Balloon in 2 seconds, 8 feet. 3 seconds, 12 feet. Okay? So it's going up at a constant rate of 4 feet per second. So you could write y equals k1, y equals k2, y equals k3. All right. Turn the page here. I want you guys to do, this is on page 110. Do number 1, how can you represent a proportional relationship within an equation? Well, it's right there. Number 2, it says generalize. How can you use an equation to find an unknown value in a proportional relationship? So I wrote down use K, which represents the constant. I put that in parentheses. Mr. Moore, question? Okay. And plug in the known value and find the unknown. And so I gave you 2 equations that you could use. Y equals kx or K equals y over x. Number 3, it says, why does the equation y equals 3x plus 5 not represent a proportional relationship? Well, if it was just y equals 3x, that could be a proportional relationship, but we've got a plus 5 there. The equation is not in the form of y equals kx. This would be in the form of y equals kx. But when you add a plus 5 or a minus 2 or whatever it is, that's not in the form of y equals kx. Y is not a constant multiple of x. All right, 4, I circled A, B, and C. It says determine whether each equation represents a proportional relationship. If it does, identify the constant of proportionality. So look at this equation here. Y equals 0.5x minus 2. So here's what we're looking at. Y equals kx. Is A in the form of y equals kx? No. So no. Here's B. Y equals 1000x. Is that in the form of y equals kx? Yes, it is. And then it says, what's the second thing we have to do? If it does, identify the constant. Mr. Quaylar, so what's the constant in this equation? Y equals kx. 1000. So I'll put down 1000. Or you could put 1000 equals k or k equals 1000. Either one will work. Make sense to you guys? Letter C. Ms. Persinger. Y equals x plus 1. Is that in the form of y equals kx?
Yeah.
y equals x plus 1. Yeah, no, it's no because of the plus 1. So the answer is no, it's not. So you can't identify the constant. But I will say this, and this is important. Everybody write this down, y equals x. Okay? Now, okay, y equals x. Whenever you have a variable set up like this, y equals x, and there is not a number in front of x, there's always an assumed 1. So in this case, y equals x, I could rewrite it as y equals 1x. So in this form, there is a constant, there is a k, and it happens to be 1, but we just don't bother writing it down. Okay? And that will come into play a few times in the future. Number 5. Excuse me. Number 5, manager of a concession stand estimates that she needs 3 hot dogs for every 5 people who attend a baseball game. If 1,200 people attend the game, how many hot dogs should the manager order? So I'm not looking for the answer, but I just want to know how to set it up. Miss Keith, what do you think? How would I set that up?
You do 1,200
Divided by 3?
5.
Yeah, divided by 5. Okay. That's going to equal something. Okay. And then, Miss Keith, I'm going to stay with you. We divided 1,200 by 5. Okay. And what's this number represent?
K.
Well, more specifically, we're talking about hot dogs, people. What would this be? The number of what's needed? What are we asking here? She needs 3 hot dogs for every 5 people. There is this many people. If we divide that by 5, we'd have, let's say it was 340. It'd be 340 what? Hot dogs, yeah. Because that's what we're trying to figure out, is how many hot dogs they need to make. And so if there was 3 hot dogs for every 5 people, and there was 1,200 people, divide that by 5, and then that would tell you how many hot dogs you need. All right? 6, circle that. 7, 8. 9, 10. Do those. 11. The weight of 3 eggs is shown. Assuming the 3 eggs are all the same weight, find the constant of proportionality. All right. So it's 3 eggs. Looks like they weigh 120 grams. So that's going to be 120 divided by 3. What's that going to equal? That's going to be 40. So the constant is 40 grams. Y is the total weight. X would represent the number of eggs. So do 12 A and B, 13 A and B, 14. Let's see here. It looks like I set up A for you. The value of a player's baseball rookie card began to increase once the player retired in 1996. The value increased by $2.52 each year since then. Since when? 1996. Then it says, how much was the baseball card worth in 1997? Well, that's just a year later. So it's worth $2.52 more. And then 1998, well, that's 2 years later, so it's going to be 2 times that. 1999, 3 times that. Okay. Yeah. So I'll let you guys answer that question. So you're going to answer it for all 3 years. Scratch out B, I'm not worried about it. 15, higher order thinking. I set it up for you. Scratch out B, not worried about that. It says a car travels 2 1/3 miles in 3.5 minutes at a constant speed. It says write an equation to represent the distance the car travels, D, in miles for M minutes. So I just gave you a little help with that. It's going to be 2 1/3 divided by 3 1/2. But I still want you to write an equation, okay, for D miles in M minutes. See if you guys can do that. 16, fill out those boxes. And 17, A, B, C, or D. Okay. All right, I'm going to end this video. So this, you guys only have a little over half an hour, so you'll get a good start on this. You'll have, you'll probably, most of you, I don't think you'll finish it, so that'll be, whatever you don't finish is your Friday work. Okay? So I'll end the video.